Physical properties of cyanides. The lower members are colorless liquid with a strong characteristic sweet smell. Lower members, that is less number of carbons, that is up to 14 carbon, contain cyanides or colorless liquids with sweet smell. The higher members are, that is more than 14 carbons are present, means there are exist as crystalline solids. There are moderately soluble in water but freely soluble in organic solvent. Slightly soluble in water, that is polar solvent, and freely soluble in organic solvent. And there are poisonous. Lower members are colorless liquids, higher members are crystalline solids, freely soluble in organic solvent and partly soluble in water, and poisonous. 3 points are given in this paragraph. They have high boiling point than analogous acetylenes due to their high dipole moment. So, compared to acetylene, these compounds having higher boiling point. Physical properties over. Next one, chemical properties. Chemical properties of cyanides. 3 headings are given. First one, hydrolysis. Second one, reduction. Third one, condensation reaction. Hydrolysis means addition of water. On boiling with alkali or dilute mineral acids, the cyanides are hydrolyzed to give carboxylic acid. Already you know about this reaction. Cyanide on hydrolysis, first it will give amide and then hydrolysis takes place, means that amide will give carboxylic acids. Usually CN on hydrolysis means finally it will give converted to acid. CN it will converted to carboxylic acid during hydrolysis. See here CH3CN, hydrolysis takes place, means hydrolysis means addition of water. Here hydrogen is added and oxygen is added to this carbon, means you will get CH3CONH2. See here hydrogens H2, hydrogens are added to nitrogen, means NH2. Oxygen is added to carbon, means you will get C double bond O. CH3 C double bond O NH2. Again this amide on hydrolysis means it will give acid. Here also water only added. Here hydrogen is added. Here the remaining OH group is added. Here hydrogen is added means NH3, that is not given here, and this OH group is added to this carbon, means you will get CH3COOH, that is acetic acids. So on boiling with alkali base or dilute mineral acid H plus, hydrolysis takes place, means the cyanide hydrolysis to give carboxylic acid. Next one, reduction. Reduction means addition of hydrogen. CH3CN, reduction means addition of hydrogen. 2H2, totally 4 hydrogen. 2 hydrogens are added to nitrogen and the remaining 2 hydrogens are added to carbon, means you will get CH3 CH2 NH2, CH3 CH2 NH2. On reduction with lithium aluminum hydride, nickel hydrogen. Here nickel hydrogen is taken, or lithium aluminum hydride can also used for this reduction. In presence of this reducing agent, reduction takes place and alkyl cyanide yields primary amine, because NH2 is called as amine. This NH2 group means that is called as primary amine. If that nitrogen contains 2 hydrogen, means that is called as primary amine. Third one, condensation reaction. Through nitrile condensation. So in third heading, condensation reaction, two reactions are given. One is Thorpe nitrile condensation, another one Levin-Hauser acetylation. So first one, Thorpe nitrile condensation. What do you mean by condensation? Small molecules are combined together and to form large molecule with or without elimination of small molecules like water, carbon dioxide, means that is called as condensation. Condensation means small molecules are combined together. Here that small molecule is ethyl cyanide. Small molecules are combined together and to form large molecule with or without elimination of small molecules, means that is called as condensation. Here that small molecule is ethyl cyanide. Two molecules of ethyl cyanide are combined together and to form one big molecule, that is 3-imino-2-methyl pentane nitrile. See here, in Thorpe nitrile condensation, two molecules of ethyl cyanide are taken, CH3CH2CN, CH3CH2CN. This H plus is removed and this bond will attack to this carbon, means already this carbon having 4 bonds, here 3, here 1, totally 4. If this bond is formed between this carbon and this carbon, means this carbon get 5 bond, that is unstable. So automatically this bond comes out and form minus, that minus take this H plus, means forms NH. So a new bond is formed between the CH and this carbon. Between the CH and this carbon, new bond is formed. After forming that bond, immediately this bond comes out and form minus, so double bond is present. That minus take this H plus, means forms NH. With this CH, one CH3 and one CN groups attached. With the CH, one methyl and CN groups are attached. So this is called as Thorpe nitrile condensation. Self condensation of two molecules of alkyl nitrile. Here that alkyl nitrile is propane nitrile containing alpha hydrogen. Alpha hydrogen means next to the functional group. Here the functional group is CN. Next to the functional group is called as alpha carbon. That carbon contains hydrogen, means that is called as alpha hydrogen. In presence of sodium to form iminonitrile, that is 3-imino-2-methyl pentane nitrile. Next reaction, Levin-Hauser acetylation. Acetylation means addition of acetyl group. So the nitrile containing alpha hydrogen also undergo condensation. Here also condensation takes place with the ester. So here alkyl cyanide, it is reacted with ester. Ester means already you know, RCOOR structure containing compound is called as ester, or COOR. Instead of alkyl group, here ethyl is given. Like that, here also instead of R, ethyl is given. So this is ester. This is called as ethyl propionate. Ethyl 1, 2, 3 carbons of propionate. So the nitrile containing alpha hydrogen, here ethane nitrile is given, also undergo condensation with the ester in presence of sodamide NaNH2 in ether to form ketonitriles. This reaction is called as Levin-Hauser acetylation. The reactions involves the replacement of ethoxy group OC2H5 by methyl nitrile, that is CH2CN. Instead of OC2H5, CH2CN group is attached. This is called as cyanomethylation reaction. Levin-Hauser acetylation or cyanomethylation reaction. See here also it will ionize H plus and the remaining minus. Electron rich attacks electron deficient. Attack means bond formation. CH2 using that minus and make bond with this carbon. That carbon already having 4 bond in its surrounding. If this bond is formed, means that is 5 unstable. So automatically one bond must be break. So this bond break and this group is removed, that is C2H5O is removed, and take this H plus and it is removed as C2H5OH. That product is not given in this reaction. After moving that, CH3CH2CO, CH3CH2CO and one bond is formed between this carbon and CH2. So, C bond CH2, with that CH2 CN is attached. So, this is called as 3-ketopentane nitrile, because it is contain, this compound contains 5 carbon, 1 2 3 4 5. So, pentane nitrile. Other than that nitrile group, ketone groups also present. So, that ketone group are present at the third carbon, 1 2 3. So, this is called as 3-ketopentane nitrile. So, chemical properties over. First one hydrolysis, second one reduction, third one condensation. Hydrolysis means addition of water. Cyanide on hydrolysis means it will give acid, carboxylic acid. And reduction, CH3CN, reduction means addition of hydrogen, means cyanide gives amine, primary amine, NH2 group. And condensation, two condensation reactions are given. One is Thorpe-Nitrile condensation, another one Lewinhauser acetylation. In Thorpe-Nitrile condensation, we will get iminonitrile, and for Lewinhauser reaction, we will get keto-alkane nitrile. With this reaction, cyanide parts over. Next topic, alkyl isocyanide. It is otherwise it is called as carbylamine. Nomenclature, that is naming. There are commonly named as alkyl isocyanide. Alkyl isocyanide. Alkyl, methyl group is present. So, methyl isocyanide, ethyl isocyanide, propyl isocyanide, phenyl isocyanide. So, this is the common name. And for IUPAC name, it is named as a alkyl carbylamine. Here methyl, and this is called as carbylamine. Methyl carbylamine, ethyl carbylamine, 3 carbons are present. So, propyl carbylamine, phenyl carbylamine. So, for nomenclature you have to remember 2 points only. For common name, the rule is alkyl name plus isocyanide. For IUPAC name, alkyl name plus carbylamine. These are the rules for nomenclature of isocyanide. Next one, methods of preparations of isocyanide. In that preparation, totally 3 headings are given. First one is from primary amine, second one from alkyl halide, and third one from N-alkyl formamide. These topics we will continue in our next video. Thank you.